That way it's in the video and you have it. Okay, so a standard deck of 52 playing cards is used. One card is drawn and not replaced. So the province has asked students to make their own question where you have two events that are dependent. The best way to do that is to just talk about something being removed and not replaced. Like that's one of the best ways to do that. A second card is then drawn. Determine the probability of drawing two hearts. Before I do this, I have to tell you that they will tell you what happens first and then what happens second. They have to, okay? In this case, they're both hearts. They're both the same, so it doesn't really matter, okay? So we started with 52 cards. We have 13 hearts. Since you're not replacing this first card, your probability for that second event goes down to 51. And since you grab the heart, this goes down to 12, okay? So 13 times 12 is 156. 52 times 51 is 2652. How are the answers? Are they as fraction or this is 2a? Yeah, they flipped the answer, so I got to fix that. So, but this is the answer to A, okay? That's what you're expected to have there. One card is drawn, then recorded and replaced. Fact on emphasis on replace. Drawing two hearts would be 13 over 52 times 13 over 52. That's 169 over 2704, okay? I'm gonna do question 3 just to make sure you have one more that I went through. Just so you know, you have to understand that this is an and, because you're drawing, like, both of these things have to happen one after the other. So it's this and the next. It's not an or case. It's not where you say this and that or something else. Like, this is it. Like, it's just, you have to have both. That's why there's a multiplication happening. So let's do the milk box of chocolates here. Probably randomly selecting two chocolates that are the same type without replacement. So this is dependent probability. Okay, so we have 4 and 3, that's 7, and another 3 is 10 in total. So that's important. So we'll have milk chocolates, right? So we go 4 over 10 and then 3 over 9, like that. So that's one case, because remember, you're taking two chocolates and you want them to be of the same kind. So this is case 1. And then the next case is you reset, and now you want the dark chocolate, so it's 3 over 10 times 2 over 9, okay? So you almost forget about that case, now you're considering this case. And then, again, we have 3 left, so it's be 3 over 10 times 2 over 9, like that. And I will let you figure out, I guess it's 90, right? It's so it's always 90, and this is 12. This is still 90, and that's 6, and another 6. So that would be 1824 over 90. That is without replacement. Are the answers to this one wrong as well? This one was okay? But the second one is determine the probability of selecting a milk chocolate, then a dark chocolate if you eat the first chocolate. Okay. So a milk chocolate, we start with 10. We've got 4 of them. And then a dark chocolate, you're down to 9 because you removed a chocolate in general. But the 4 milk chocolates, right, that is not even part of this. You're still down to 3 dark chocolates. That has not been affected by the first event, the number of dark chocolates. So this would be 12 over 90. So that's kind of what we were looking at here with this assignment. Are we good? Question? You were good? Okay. All right. So I'm going to stop this, and we're going to do